Hello, everybody. Time for another investigation with sine and cosine. Today, we're going to be talking about phase shift. Okay. And we're going to be talking about how we can shift our function from the left to the right or right to left, whatever. We've already learned about vertical shift, where we can move our function up and down. And we've learned about amplitude, which is the swing in height above and below the midline. So now we're going to talk about moving our function to the left or moving to the right. So let's go ahead and adjust our window. And kind of like we did before, we're going to have the x value be negative pi. Okay. The right value will be 2 pi. And of course, our calculator turns it into decimals. It's okay. Uh, this was pi over 4. So if you had to, the x scale will be pi over 4. Mine's already there from the last time, so I'm not going to switch it. And then for our heights, we're just going from -2 to 2. And we're keeping that scale as 1. And if you take a look at your graph, it should look something like this. Remember that each of those tick marks here represents pi over 4. And each of these tick marks here represents 1. So let's go ahead and let's graph our first function, y equals the sine of x. We all know what that looks like right now. Okay, boom, there it is. You can now see to the left of it a little bit, left of the y-axis. And to the right, we're going to 2 pi. So basically what you see to the right is 1 full period. Now, let's think about, oops, that's not what I meant to do. Let's think about what would happen when we put this equation into our calculator. And as you're putting that into your calculator, I want you to think about parabolas from last year. When you subtracted or added something inside the parentheses, what was the effect of that? I know in my class, I would always say opposite same, over and over and over again. And it is actually the same thing for this function because this function works like any other function. And what you'll see is that by adding pi over 2, the function actually shifted to the left pi over 2 units. And we don't use the word shift. We're going to use the word translate. So it was translated pi over 2 units to the left. Okay, so opposite. Let's go ahead and do y equals, and let's do the next one. Okay, and what do you think subtracting pi over 4 is going to do? So we're over one more. We're going to subtract pi over 4. Okay, so again, think about our parent function. I want you to think about opposite same. So this is opposite. There's our parent function. And what you should see is that it moved it pi over 4 units to the right. Remember, each of these tick marks is pi over 4. So it translated it pi over 4 units to the right. Okay? So maybe we don't even have to do this one on the calculator. Maybe we can just think about it. If it says cosine of x plus pi over 4, and that pi over 4 is all inside the parentheses, hopefully you can figure out that it's going to translate it pi over 4 units. And because it says plus, it will actually go in the direction of negative. So pi over 4 units to the left. Whereas this one says the cosine of, and then in parentheses, x minus pi over 3, it will translate it pi over 3 units to the right. Okay, so again, opposite same. If you see a minus in here, it's going to bring it in the positive direction. You see a plus in here, it brings it in the negative direction. Okay, so you can go ahead and write your description down right here and then make a prediction right here. It says the sine of x minus 3 pi over 4. Maybe you got it already. I hope so. I hope that you're thinking, translate 3 pi over 4 units to the right. Okay, and again, when it says subtraction, it will move it to the positive direction. Okay, so it's really the opposite of what you see in there. So let's turn to the next page. And on the next page, we have some information up at the top that you can read. Okay, it's a little bit of what we just talked about. To calculate the right endpoint, so this is important, we have to add however many units we're moving plus the period. Okay, so in all of these cases, if we wanted to find the right endpoint, we would have added whatever the shift was plus 2 pi. And so we'll get into that in a little bit. Here are some equations. We're kind of building on our equations. Amplitude times the sine of x minus the c value. That's the left to right shift. So that's the horizontal shift, plus d, which is the vertical shift. Okay. Then, of course, we have some equations here that we're going to be needing. So let's talk about the sine equation first. I'm going to give you a little bit of help on some of these. So for the sine equation, our left endpoint is 0. Our right endpoint is 2 pi. And in order to find the midpoint, and we're going to need that for graphing purposes, we really just average 0 plus 2 pi. 0 and 2 pi, which of course we know what that is. Okay, it's just going to be pi, but I want you to have an example for these problems. So let's go ahead and let's do number 10 together, and you'll be doing the rest on your own and might struggle a little bit, but that's okay. So for number 10, remember the left endpoint is going to be the opposite of what we see here. So we see negative pi over 4, so the c value is pi over 4. The right endpoint is going to be that plus 2 pi because the period is 2 pi. So we would write that as 2 1/4 pi or 9 over 4 pi, depending upon what we're doing with it. I'd say for graphing purposes, we would probably write it as 2 1/4 pi because then we can easily find that on our graph. So in order to find the midpoint, now we're going to have to average the left value, the left endpoint, and the right endpoint, and find out what's right smack in the middle of those two. I'm going to have to write big here. So it's going to be pi over 4 plus 2 1/4 pi, all divided by 2. So when you add those together, you should get 2 1/2 pi divided by 2, which is 1 1/4 pi. Okay, and if you wanted to write it as 5 pi over 4, that's the same thing. But again, we're going to be graphing, so this is probably what you'd want to look at because we're going to be able to easily find that on the graph. Okay, so that's pretty much all I have for you today. I want you to go ahead and try 11 through 14. Okay, take your time. Some of them are easier than others, but you should be able to do just fine. Have a great day, everybody.